Welcome to part 6 of this 12-part series in learning the Dart programming language. In this section, we cover the very important topic of functions. If you plan to move on to Flutter, this is one section that you want to pay particular attention to. So let's not waste any more time. So here we'll define what a function is. Here's a general definition of a function in computer programming: a segment or logical block of code that performs a defined task and returns a value. There are built-in functions. In Dart, we have the print function, which we've already been using, and there are user-defined functions, which is what the bulk of this class will be about. What do they enable us to do? To reuse the function so we don't need to repeat ourselves. In this way, our code would be said to be dry. That stands for don't repeat yourself. Then it's also modular. It divides our code into smaller, more manageable chunks. Functions in Dart. Dart is a true object-oriented language. So even functions are objects and have a type of type function. This means that functions can be assigned to variables or passed as arguments to other functions. You can also call an instance of a Dart class as if it were a function. Now, we've already been using functions. The main function, Dart won't work without that. The main function is of type void, and what that means is it has no return value. We're going to learn all about that in the upcoming slides. Coming from a programming language like Python, it's much easier to get your arms around when you see a function. In languages like JavaScript, and even in Dart, sometimes it's harder to understand. And I find that this is a very important concept once we get to Flutter. So what I have here for you is a reference. The numbers that you see in parentheses are from the Dart language specification. But I want to go through briefly. There are at least 6 ways to create a function in Dart. We can do it through declaration, a function declaration that has a name and a preface type like int, and a body where statements go. Then we have method declarations. This really gets into object-oriented programming. So let's save that for when we get to classes. But just know, I've said it before, a function is a function unless it's in a class, then it's called a method. And we have instance methods and static methods. And we'll get to those. Then we have getter declarations. Getters are functions that are used to retrieve values of object properties. Setters are just the opposite. Setters are functions that are used to set values of object properties. Then we have constructor declarations. Again, this is something that is specific to classes, right? Classes have this notion of a constructor. We're going to get to that. Then we have function literals. We've already seen some arrow functions. Sometimes they're called lambda. Sometimes they're called fat arrows. And we're going to get to this. It's a function literal is an anonymous declaration and an expression that encapsulates an executable unit of code. They come in very handy and they're used a lot. So we're going to get to all of these. And I will warn you, I'm going to spend a lot of time here. I'm going to spend a lot of time in classes because there is a ton of documentations and videos that you can watch that will zoom you through Dart on your way to Flutter. I think that's a disservice. We are going to dive in and dissect. Hopefully we did that with collections, especially lists, here and with classes. We can't afford not to because you'll get to Flutter and it will be confusing. So an anatomy of a function. This is your garden variety function declaration. So let's review it and then we'll go for what each part and piece of this means, especially if you're new to functional programming. So we have return type, function name, parameters in parentheses. Then we have open curly brace, statements, return value, closing curly brace. This is one of the easiest function types to identify. So it should be very familiar to you. It's used a lot. So let's go through each of these. We're going to start with return type. This defines the data type the function will return. You might see it as int for integer, void. Void is the type that returns nothing. String to return a string. Then we have a function name moving to the right. This is a user-defined name. You can call it what you will. Conventions for different programming languages are different. Usually in Dart, we have camel case, so we start lowercase and go uppercase, or just use all lowercase if you don't have two words or anything like that. But myfunct1 is an example of what you could do. Then we have parameters. Functions allow us to pass in parameters that the function will use as part of its statement, like a name or a number. You don't have to have these, right? These are optional. Some do, some don't. But a lot of the more sophisticated or more complex functions will have these. Why? You want to bring data in that you act on with your function. So you bring this data in, you manipulate it in your statements, and then you return a value based on the logic of those statements. That's generally how it works. By the way, statements are what are defined in a function. It's what's defined in the parentheses of a function. Arguments are what are passed in when we get to callers. Sometimes people use those interchangeably, but technically there's a difference. Parameters are used in function construction. Arguments are used to marry those parameters when one is calling the function later in the code. Statements are the heart and soul of the functions. They are the things that get executed in the body of the function that enable a value to be returned. For instance, I might have a statement like var val1 equals 7 times 10. And if I was using parameters, it might be var val1 equals num1 times 10, that type of thing. That's how we get to use parameters and the arguments that get passed in to marry them to then manipulate in the statement. Then return value. Okay, so here's where it all culminates. Most functions return a value after the statement in the body is done executing. Think of a built-in function like a print function. We feed it in a string and it displays at the console, right? So that's what it returns. It returns a string. So we're going to go over more of this and get into examples, and hopefully this gets reinforced. So now we make the function real by going through our very first example. So we have void main, and again, we need main as the entry point for any of our code. So it is a function as well, by virtue of the fact that void is the data type that sits before the main. We know that it returns nothing. The return type in this case is string. The name that we gave it using camel case is print me, right? So print me, print lowercase, me uppercase. We have one parameter called word. It's of type string. Then in the body of the function, we have a statement. Inside our curly braces, string print word equals word. So yet another string called print word, which uses now the word parameter. So that means we're going to be passing in an argument to correspond to that word variable. Then we simply return print word. Now we have our function callers. Every time we call the function, we are reusing our code instead of recreating our code. So what does that do? That saves time. That makes it so we have less errors. That makes it so it's easier to troubleshoot. It's all in one place for us. So look at how we print this out. We have print me, which of course is the name that we've chosen to give to our function. And then in quotes, it has to be quotes because we know it's expecting a string type. We have hello. And then we have our second caller to emphasize this all the way around. And we have print me goodbye. So print me hello, print me goodbye. What gets printed is hello from the first caller and goodbye from the second caller. What do you think would happen if we didn't wrap this in a print function, the user-defined print function? Well, the code would execute without error if we just had print me hello, but we wouldn't be able to see it. Right? We wouldn't be able to see it at the console. We have to print it to be able to see it. So hello and goodbye are known as our arguments. Those are the things that take the place of word or correspond to word. Think of it as word equals, and then whatever we pass in, it's hello and goodbye. Every parameter needs a corresponding argument to be passed through by the caller if we are to make use of it. All right, so let's get inside the function's head to make sure we understand exactly what's going on. A function will do exactly nothing unless it's called by a caller. When a function is called by the caller, control of our program is transferred to the function so its statements can execute. Once statement execution is completed, control is returned back to the code that called it, or the caller, along with the return value. In our case, the string hello in the case of our first example and goodbye in the case of our second example. Then our program continues to the next line of code right after the caller. We know we need a main function to make Dart work, but nothing says we have to define our function inside of it. Here we move our function outside of main. So I have string print me, string words, same exact thing, but I call the function from the main function. I don't define it there. And what is the result in this case? Same thing. It'll print out the string inside of the parentheses in print me, which is calling you from the main function. Now you may be wondering, does it matter where I have my function relative to the main function? In the previous example, I had it before the main in order of appearance of our code. Now I have it after the main. It doesn't matter in Dart. Everything will work exactly the same. Okay, so we'll check out arrow functions. So function shorthand you are sure to see. This is called shorthand syntax, expression syntax, arrow syntax, fat arrow syntax, and probably a whole bunch of other stuff that I haven't. Oh, lambdas. Sometimes they call this lambdas in Dart. It is a type of function expression. You can only use this shorthand syntax with an expression, not a statement after it, so there's no for loops or if statements. It is known as a function expression. So here it is down at the bottom. It's of type bool. We're giving it a name of isTrue. It has one parameter called truthy of type string. And then on the other side, we assert that truthy is equal to yes. And so when we call it, we can call it 3 different times. If I have yes in there, it'll come to true. If there's no in there, it'll come out to false. So it's very straightforward. You are going to see these a lot in your code, so you should get used to what they look like, so you're able to recognize them. Okay, let's get a bit more into parameters. A function can have 2 types of parameters, required and optional. The required parameters are listed first, followed by any optional parameters. Optional parameters can be named or positional. Note here, Flutter widget constructors only use name parameters, and you'll see that once we get on to the next series in Flutter. Optional parameters can be either named or positional, but not both. Default parameters are parameters that can be defined in absence of one being passed in when the function is called. Positional versus named parameters. Positional parameters are referenced based on which position they are in when they're defined and called. Here's an example. We have a function called myfunc with 2 parameters, param1, param2. The param1 parameter will always be addressed first. That's because it's a positional parameter. Dart needs to know what your intentions are, and the way it knows this is by what you do when you call this, right? So the thing in the first position, the argument in the first position, will marry the first parameter. Name parameters, on the other hand, are referenced by the name they have been given when defined and called. So example again, myfunc1, string param1, int param2. By the name param1 is how this function will be referenced. All right, let's see an example of optional and default parameters, named, the whole kit and caboodle. So we have a function called dogs. It returns the type of string. So we have string name, string coat, and then string breed equals mixed. So right away we know we have 2 named parameters, name and coat, and then we have breed, which is a default parameter, and it's defined the default value of mixed. So this is all about dogs. So now we have an if statement here. If coat equals null, return name plus a dash plus breed. So we're concatenating strings here, right? Else implied, we don't need the else in this case, but if that is not the case, if coat does not equal null, right, if coat has a value, return name plus hyphen plus coat plus hyphen plus breed. So what happens when we call it? 3 callers. First one provides all 3 values. Name is Roscoe, breed is terrier, coat is long. The second one provides just the name and the breed, coat is null, so it will use the if branch. And then the third one is just the name and coat, so it will use the default breed of mixed. All right, so let's look at the first one. The first one has all 3, Roscoe, terrier, long. So what is the output down here? Just as you would expect. It uses what the user or the caller passes in as arguments for these parameters, Roscoe, Long, Terrier. Okay, the second one, it has the name, it has the breed, but the coat is null. So the first thing you have to know, this doesn't work this way in Python, you get an error, but I believe it does work this way in JavaScript, and it works this way in, no surprise, Dart. I don't pass in a value for coat. So all it tells me is, it says, okay, I bring back Rosie and Chi, but I do nothing, right? Except it's using this if branch instead of the return, the second return statement. So it knows that's null, so all it's going to do is bring back name and breed. So on the third example, just the name and the coat. So now, this will be the first time that it's going to use the breed of mixed. So what happens? We have Duke, short, and for the value of breed, it uses our default mixed. That's how it works. So since we know that defined parameters in Dart are not required, you would figure that Dart is smart enough to have a required attribute, and it does. If we want to make a parameter required, we can use the @required decoration. To do this, we have to do a couple of things. We have to ensure we have a pub/spec.yaml file in the root of our Dart project. This is like a configuration file. And I give you an example here of what your basic YAML file is. You can create this yourself if you'd like. Pub/spec.yaml. It has name, description, version, author, and then dependencies. The one that we are particularly interested in is the meta dependency, meta:*1.2.2. We must add the meta external package as a dependency for our project, and hence the YAML file as you see here. Very important. And sometimes the syntax or the text inside of this file can get a little wonky, so you want to make sure that you have it exactly as I have it with the indentation. Then from within your project, issue the following command from the command line, pub/get. Then we must include the import statement in the file where you're using the required decoration, and an example will be coming up. Finally, we place the @required decoration in front of the parameter you wish to make required. All right, and as promised, here is our example. You see down here in our dogs function that we used in the previous slide, we now have the @required string personality. So now I'm requiring the named parameter personality. And notice up here in my callers, telltale sign, I use VS Code, as I know you know. I have squiggly lines underneath all three of my callers. Why is that? VS Code is alerting me to the fact that I have not used the requisite or required personality parameter. Contrast that to what I have on the right-hand side. Now in line 45 in the right-hand block of code, dogs no longer has the squiggly line. Why? Because I have parameters included in all three of my callers. Now I want you to see the import statement, and we'll cover import statements. We have up at the top of both of these segments of code, import, and then in quotes, package, :meta/meta.dart. It won't work. You'll get an error if we don't include that. If you are coming to us from JavaScript, you know that there are anonymous functions. So most functions are named, such as main, or when we define our own functions. You can also create nameless functions called anonymous functions, or sometimes a lambda or a closure. You might assign an anonymous function to a variable so that, for example, you can add or remove it from a collection. An anonymous function looks similar to a name function. 0 or more parameters, so you don't need to have parameters, same as in a defined function or named function, separated by commas and optional type annotations between the parentheses. The code block that follows contains the function's body. So here I give you the example of the syntax. All right, so here is example number 1 and number 2 of using an anonymous function. So what I have highlighted here in this light grayish tone is the whole of our anonymous function. It's passed into the for each built-in Dart function as its one argument, right? Here's an example that we're using a function as an argument, right? That might be foreign to you, but it's very useful. Down at the bottom, we're using the arrow function. It's still an anonymous function, but the syntax is just slightly different. Can you compare the two? And can you see what will happen here? For each element in our list, my list, the function body will apply. And in the body is a print statement applied to each element of the list. So when we're done calling these functions, it will simply print out 1, 2, and 3. Both will work exactly the same way. I'm really focusing in on different examples for anonymous functions because you're going to see them a lot. And sometimes it's hard to recognize them, right? So I want to make sure that you become very familiar with them. In this particular case, we're using both the expand and the toList built-in functions for Dart. And in between, we're sandwiching in our anonymous function. So expand, much like for each, is going to expect an argument in the form of a function. And anonymous functions are just perfect for that. So let's look at this. In our main function, we have a list called input with 3 elements, A, B, and C, all strings. Then we have another variable called duplicated. So duplicated equals our expand function. We're using the input, our list, as the value that we want to expand. Then we apply the anonymous function and we convert it to a list. So once we print this all out, we will get A-A, B-B, C-C, Y, EL, and again, we can call this anything. EL is our element. In the body of our function, our anonymous function, we are concatenating strings. EL plus dash plus EL. So it works like a for loop. Every time I go around, I advance to the next element in my list, and I apply whatever's in the body. So A plus the dash plus another A. Then we increment B plus a dash plus another B, etc. And we convert that to a list, and that's how you see the output. Now we really did assign a function to a variable in our last example, but here it is again. We have uppercase me, then we have MSG as our one variable, MSG, Madison Square Garden. Then we have our arrow, and then on the other side of the arrow, all we're doing is using string interpolation to take whatever we pass in for the parameter message as an argument, and we convert to uppercase. So again, we're using a function inside of a function. And then it's very portable, right? We can use uppercase and do whatever we want to do with it. It becomes another print function, except this one is fancy. Whatever you throw in there, it turns to uppercase. The sometimes confusing topic of scoping and nested functions. Dart as a language is lexically scoped, which means the scope or the sandbox, you can think of it that way, in which variables can be accessed is determined by where the variables are defined in your code. So, what do we have here? We have a top-level string called top level. I'm from the top level. Then we have our main function inside of main. We are printing lexi, which is a function outside of main. Then we have foo, a variable string, and then we print foo. Then we have lexi defined. There's a string in lexi also called foo. I'm from lexi. Then we have string yo, which is inside of the body of the lexi function. We have a var foo yo, I'm from yo, and then we return foo yo plus a dash plus foo plus top level, and then we print foo and we return yo. So let's find out exactly what's happening here. So code executes from top to bottom, but it also has to jump around to execute all called functions in order of appearance. So main calls lexi. Okay, you see that in the print statement in the first line of code. Then lexi's body executes. Lexi itself defines yo, but nothing in yo prints yet until it's called later in our code. We keep traveling the file, and the first thing to print is foo. And what is the string that it prints out? I'm from lexi, as defined in lexi. Because yo is defined inside of lexi, and then the foo that is used is the first one it finds traveling back up the nested function tree. Then yo is called. As a consequence, its return statement is executed, printing foo yo, almost like froyo yogurt, from its body, plus foo from lexi, plus the top level variable from the top level of our code. Finally, we execute the print statement, which is the last line in the main function. So it prints out, I'm from Lexi, I'm from Yo, I'm from Lexi, I'm from top level, and then I'm from main. Study this a while. Let it sink in. Make sure it makes sense. Just like in JavaScript and Dart, we have what are known as closure functions. I think it's much more complicated than the nested function example that we went through. So what is a closure function? And I think it starts with the name. I always want to say that the closure function is the outside function. That's not the case. It's the inside function. So let's see. A closure is a function that has access to variables in its scope, even when the function is used in other scopes. So let's look at this carefully. Full name returns a function that concatenates the lname parameter to the function's argument. So we have string lname. You see this is an arrow function, right? First plus space plus lname. This returns the anonymous function, right? It's strange to see that, right? Right in the return statement is our anonymous function. The outer function is full name. The anonymous function, this inner function, is the closure. So we have then below our main function. Fred will be the argument for parameter first. This calls the outer function. Flintstone will be the argument for lname and is able to make use of, and remember, the full name first variable, even though it is not defined in its scope. So add ln, Flintstone, this calls the closure. Does that make sense? Take a good look at it. Full name Fred calls the outer function. Fred will be used as the argument for parameter first. Flintstone calls the closure. It will be used for parameter lname. Again, study this and take a look. And then take a deep breath, because this is the last slide in this particular class. I hope it makes sense, guys. My fine friends, thank you for making it all the way to the end. I hope you found this valuable. If you did, do a couple of things. Subscribe to the page, give me a like, leave a comment, and share this with somebody who might need it. We're trying to start a revolution here.